Hi guys, welcome back to the Art of Server, and welcome to the second video in the PowerEdge R410 build series. So today's video is all about storage, and I'm going to show you a couple of pretty interesting options for storage, and in particular if you need IT mode. So if you've been watching my channel for a while, you know I'm all about IT mode. I love ZFS, and I help a lot of guys out with their unRAID and other software RAID technology builds. And so I want to show you a couple different options for IT mode SAS controllers in the R410. Now to start, from the last video, I think you already know that there are basically two PCI slots in here. There's a white one that I'm pointing to right down here, and this is for the integrated slot. So this is not a normal PCI slot. You won't be able to connect a regular PCI card to that slot. On top of it is a black PCI slot, and this is a normal PCI slot where you can install a regular PCI card after removing this bracket in this spot right here. So first of all, this machine has very limited expansion capability, right? Because of these, basically you have one normal PCI slot, and but I'm going to show you how to make use of that integrated slot. A lot of you guys might be thinking, oh, that integrated slot has limited options. For example, there's this card, and I'll talk a little bit more about this. But if the integrated cards aren't going to work for you, then all you have left is the normal PCI slot. And so that really kind of put some limitations on how much you can add to this server. But I'm going to show you that this integrated slot actually has some options that are viable, and we'll get into how that is. Okay, so anyway, let's talk about that integrated slot. It is a PCIe by 4 slot. And I know it looks like a by 8 slot, but it's actually by 4. Okay, so there's only 4 PCIe lanes, and the reason for that is that part of the PCI slot is used for the SAS lanes. So you'll notice on this riser here is a SFF 8087 port, and there are 4 SAS lanes that traverse that port, and those are connected to that slot. Okay, so half of that slot is actually used for the SAS lanes, and that's why this card, even though it looks like a by 8 connector, is only actually by 4. Okay, and it's also PCIe 1.0. All right, but even with PCIe 1.0, a by 4 slot or 4 PCI lanes at PCIe 1.0 still gives you about 1 gigabyte per second. So that should be enough for what you need here, because we're really only talking about 4 hard drives. Okay, there's really not more that you need with 4 hard drives, and even with SSDs, you might be able to saturate that bandwidth, but this is a 3.5-inch form factor, so the chances of you using SSDs on this are probably pretty low. Okay. All right. So with that said, this card that I'm holding here is the Dell. This is an original Dell part number here. Let me see. Is HM030. So I'm going to try to put this in the camera. If it doesn't show, I'll take a picture of it and throw it up in the video for you. Okay. But this is Dell's SAS6i/R card, and this is basically originally with Dell firmware. It originally is a IR card, so kind of more or less a RAID card, a very low end RAID card. As you can see, there's no cache memory here, so it's not a very performant RAID card. But we don't care about RAID, right? We care about IT mode, and there is actually a way to flash this to IT mode, and I'm going to show you guys that today in this video. All right. So this uses the LSI, and if you can see the chip printing here, it's an LSI 1068E. Okay, and I'm going to go show you how to download the firmware. There's actually a few of them, And you need to look at this chipset and see what revision it is, because there's different firmware files for the different revisions of this chipset, and that's something you need to know. We can also find the revision using a program to extract that information later on when we fire this thing up and get on the console. Okay, so anyway, with this card in IT mode, you're basically going to get access to all 4 drive bays directly for you to use something like ZFS or Unraid or any other software RAID technology. Okay. All right. So I actually took this card out because I'm kind of thinking that after you watch this video, some of you might be interested in getting this. So I'm going to show you how it gets installed. Okay. So again, it goes in this white PCI slot down here. You basically place this card down here, and there are these little notches on the side of the card that allow these hooks on the side here to go through, so that you can actually get past that. So you want to make sure that the card is going to slide under those hooks. All right, and so once you kind of get it placed down, line the connector into the slot. And then all you have to do, and there's a little retention spring plastic clip down here with the blue dot. You want to press down on that a little bit, and just make sure the PCB board here is going to slide under those hooks, and then just press it in until you see this retention clip basically hook onto the card. So that's how you install the card. Now to remove the card, I'll show you that as well. You take this blue plastic lever here, and it's kind of, how do you say it? It's kind of secured into this little hole here with a small pin. So you have to press down on that a little bit, and then pull this. Oh, sorry. You have to also press down. Remember, this retention spring thing is going to hold the card in. So hold this down, and then pull this lever out. And that helps you pull the card out of the slot, and then basically you can take it out at that point. Okay, but when you're installing this, you want this in the fully engaged position. You don't actually need to use this to leverage it in. It doesn't, it doesn't attach to anything to pull itself in. So you just simply keep it closed. All right, so let me go ahead and install this card one more time. All right. So with that said, if you don't already have this card, you probably don't have the appropriate cable for it. And this does require a special SAS cable. This is not a cable that you can get, from a third party or something like that, because it's kind of unique. All right, so this is the cable, and the cable part number is C0, C069M. Okay, and by the way, I'm going to leave links to these products in my store. So if you decide that you want some of this stuff, go check out the links in the description of the video. But this is a special cable that basically takes an SFF8087 connector, which has 4 SAS lanes, and splits it into 2 SFF8087 connectors. One is a straight and one is a right angle. Okay, but because it's splitting it, these normally these SFF8087 connectors carry 4 SAS lanes, right? But because it's split, this only actually has 2 here and 2 here. Okay, and so those combine into the 4 SAS lanes on this side of the cable. All right, so it's kind of a special cable. You're really not going to be able to find something like this in the aftermarket. So I mean, if you do, that's great. And actually, if somebody knows where you can get a cable like this in the aftermarket, please leave a comment and let me know, because kind of unique cables like this are usually hard to find. So anyway, the side where the 2 cables merge together go onto the riser board. So let's go ahead and install that. Now, I just had a discussion with a customer about these SFF8087 connectors. They're a little bit tricky. And I know it sounds almost obvious, but you really need to make sure that they fully engage and click in. It's very common. I can't tell you how many times I've had someone contact me and say, hey, some of my hard drives are not showing up for some reason, and after asking them to reseat the cables, everything starts working. So so don't feel silly, if someone says, hey, try to reseat the cable, because for whatever reason, even myself, I've had that problem where I didn't fully seat these SFF 8087 connectors in, and some of the connections didn't work. Okay, so this shorter side is going to go into this place in the back plane. And remember, this is only 2 SAS lanes, so I believe this probably only connects to these 2 hard drives. And so I'm going to route this under this power cable here, and this connector kind of goes in upside down. Okay, and it's also labeled BPA for backplane port A. So let's see. Oh, you know what? Maybe that doesn't go upside down here. Let's see. Sorry. Yeah, I think I need to go in this way. All right, and again, make sure that's fully engaged. All right, and then this other cable, you need to route under the cable management hooks here. So I'll put one right there, and you can route it under this clip here that holds some of the other cables. But before I do that, I just want to make sure that everything is in the right position. So I'm going to go ahead and install it in the other backplane port here. Okay, so that looks like it's fully engaged. And then at this point, then I can tuck this cable underneath this little cable hook. All right, so that's all you need to do to install the cable for the integrated slot. All right, now that's not the only option I'm going to talk to you about today. If for whatever reason the capabilities and features of this card isn't going to work for you, I'm going to show you another option, and we'll get to that later in the video. All right, so anyway, I've got everything connected. I'm going to buckle this server up and power it on, and we're going to get on the console, and I'm going to boot off of this USB drive that has FreeDOS and some of the firmware tools. And so we're going to get on the console. I'm going to show you where to download the firmware and what files you need, because there are a few different files. And I'm going to show you how to convert this card to an IT mode SAS controller. All right, so let me just go ahead and plug that USB drive in there, and we'll go fire this guy up. First thing first, let's figure out how to download the firmware. Okay, so like I said, that card, that Dell SAS6i card, uses the LSI SAS6i chipset. All right, and that alone might not tell you exactly how to find the firmware, so I'm going to help you out with that. First thing we want to do is go to broadcom.com. Okay, and I believe under support we can find support documents and downloads. All right, so we'll go down there. So this is a really old card. So under product group, you're going to want to pick legacy products. And then under product family, we're going to pick legacy host bus adapters. Okay, now the tricky part is the product name. So you're going to need to know the equivalent product that LSI made that's equivalent to that Dell 6 or the Dell SAS6i, and that happens to be the 3081E-R. So if you scroll down here, oh, there it is. So the 3081E-R, this is the equivalent LSI product that has the 1068E chipset. And then as far as asset type, we're going to pick firmware. All right, and then do a search, and we have one result. Let's expand that. Now, I don't really know why, but they include some of the other stuff here that's not really relevant. So you want to go down to this package right here. Okay, so the SAS 3081ER package P21 IR and IT firmware. Okay, this package is going to have both the LSI equivalent of the IR firmware as well as the IT firmware. So we'll go ahead and click on download for that. And yep, so it's downloading. I'll go to the folder. Alright, so it's just a zip file. Let's go ahead and unzip this because I want to show you what's in it and what you're going to need out of that package. Alright, so this is the contents of that zip file, so we can go ahead and get out of there now. there's a couple files you're going to need. So first is the DOS. Since we're going to be doing this in DOS, you need the DOS version of the sasflash.exe file. Okay, so you're going to need that program. And it's also listed here too, but I think this is like the Windows version or something like that. So don't mind this one. Make sure you get the one under the DOS folder. Okay, and you're going to need 3 different firmware files. Okay, and the firmware files all end in FW, but you're going to need, so there's 6 of them here. And the reason why there's 6 of them is because, remember, this package includes the IR firmware, which is the RAID firmware. But we're looking for the IT mode. And so the files you want to look for will have 3081ET. The T is for the IT mode. Okay, you'll notice the other files up here is 3081ER, and that's for the RAID mode. Okay, so if you want RAID mode, you could use those. But we're talking about IT mode here. So, and there are 3 different firmware files because of the chipset revision. All right, so I mentioned that earlier. You'll see that there are these 3 files that end in B1, B2, B3.fw, right? So these correspond to the revision of the chipset. Now the one that I just installed in the R410 is a B3, and we're going to find that also programmatically by running sasflash to check on that too. But I read the top of the chip and it had B3 printed on it, so this is probably going to be the file that I'm going to need. But I don't know what revision you might end up getting, so it'll be good to have all 3 files just in case you need one of the other ones. All right. In addition to that, if you want to be able to boot off of it, you're going to need the BIOS ROM file, and that's this mpt sas.rom file. Okay, so those are all the files you're going to need. You need the BIOS ROM, you need the 3 possible firmwares, and you need the flashing tool, which is sasflash. Now I already have these tools uploaded on my USB flash drive with FreeDOS, and so we're going to go ahead and boot that right now. Alright, but I just wanted to show you guys how to download this firmware and what files you need. So let me go ahead and close that. Here's the iDRAC to the server. Let's go ahead and log in. There we go. Alright, so let's go ahead and launch. Here's the virtual console. I can minimize that. Let's go ahead and power this machine. So you'll see that we still currently have the Dell SAS6 firmware on it, and that's going to change once we convert this to IT mode. Alright, okay, it looks like it doesn't know how to boot off of my USB drive. I'm going to go ahead and hit F11 to get the boot manager, and we'll go down to hard drive, internal USB. Alright, so that's probably the one. This should load FreeDOS up. Yep, there we go. There's FreeDOS. Okay, so I'm now booted up in FreeDOS. I believe I have my files in a subfolder called LSI 1068E. You can organize it however you wish. Just in my case, that's where I've put everything. Okay, so I have basically all the files that I need here. And there's this sasflash.exe. I've replaced this one with the DOS version, so we can go ahead and run that now. Okay, now if we do a -list, we should be able to see the card. So you're going to want to run this first, by the way, because there's a couple of bits of information we're going to need from this. Okay, so the first bit of information we're going to need is the revision number. And so you'll see here it says controller is 1068E. In parentheses it has B3. So that tells us that we have a revision B3 chipset here. And that's going to tell us which firmware file we're going to need to use. Okay, so that's the first bit of information we're going to need. And the second bit of information we're going to need is the SAS address. Okay, so we're going to need this SAS address because it's probably going to disappear after we do the flash, and we're going to need to write that back into the flash, okay, or into the card. So I'm going to just write that over here, 5842B2B 0370A 6F00. Now, of course, you could also just redirect the output of this to a file, and so you have a copy of it. I'm just, going to keep it in my notepad here. So let me just double check. It's 5842 B2B0370A6F00. Okay, so now once we have that, we can now flash the card to IT mode. Alright, so we're basically going to run SAS to flash again, and we need to give it the O for advanced options, -F, and this is going to be the firmware file we're going to use. So remember, it was E3081ET for the IT mode, and we need to use the B3 revision version, and so that's the file. So it's, in this case, because it's the revision B3, we're going to use the 3081ETB3.fw file. If you have a different revision chipset, make sure to use the corresponding firmware file. Okay, and we're also going to flash the BIOS ROM on this. So mptsas.rom. Okay, so this is all we actually need to do. We'll hit enter momentarily here, but one thing I want to mention, a lot of the other instructions using FreeDOS to cross-flash LSI cards often mention doing an erase. So there's a -E option. For this particular case, I want to caution you about using that -E. I recommend not doing it at all. Okay, I actually did, and I messed up one of the cards I have that is now no longer usable. I'm not exactly sure what got erased and what caused the problem, but I just know that when you erase the flash, the card just stopped working, and like I won't even boot, so I can't even actually try to fix it. I may try to do something with it at some point. If I can figure out how to fix it, I'll make a video about it, but I just want to caution you guys, if you're used to running a -E to erase the flash before you flash it, don't do it in this case, because you could end up bricking the card. Okay, so anyway, let's go ahead and hit enter here. Alright, so it's going to say that the product and vendor ID do not match. Would you like to flash anyway? You just answer yes, and that's just because we're going from the Dell card to a LSI firmware, and it says we're flashing from IT mode over IR firmware. Do we want to do that? Yes, we do. Alright, firmware download successful, firmware flash successful. So that's all good news. That's exactly what we want to see here. Now it's resetting the adapter for it to load up the new IT firmware. And next step here, we're flashing the BIOS. Alright, so that's it. Now we're done. Now if we do a SAS flash -list, we should see this in the IT mode firmware. Alright, so there we go. So now you'll see that NVData vendor is now a LSI Logic. Okay, it's no longer Dell, and this is identifying the card as a SAS 3081E, right? So this is the LSI equivalent, and it's still the same chipset, but we now have the IT mode firmware on this card. Alright, one thing is that the SAS address seems to be still intact, so that's good, but I will caution, I've done this several times now, and sometimes that SAS address disappears. So I do recommend that you write that down anyway, just in case you need it. You can program it back in. Now if you do need to program it back in, I'll show you what the command is. Basically you run SAS flash -o SAS add, and then you enter the SAS address without any dashes. Okay, just the hexadecimal values. Okay, so that's all you need to do to program the SAS address back in. So yeah, so that's it for programming this into a IT mode controller. I'm going to now shut this down. I'm going to put my CentOS 7 USB drive and boot this up in CentOS and show you guys what we got there. Okay. Alright guys, I just plugged in the CentOS 7 USB drive. Let's go ahead and power this machine back on. Alright, so now instead of the Dell firmware, you're going to see the LSI MPT SAS BIOS here. And as you can see here, we have SAS 1068E-IT, so that's the IT mode firmware. Let's go ahead and log in here. Alright, first thing, let's check that we actually have this card. Alright, so we have a SCSI storage card, that's the SAS 1068E, and the subsystem vendor is still Dell, and the subsystem product ID is still the SAS6i/IR integrated blades RAID controller. So that part, by the way, is I believe pretty important here. Now, if you notice, in the process of flashing this card, we did not mess with the SBR, and we definitely don't want to do that. A lot of the firmware cross-flashing processes mention wiping out the SBR with an empty file, and you definitely don't want to do that here, because if you wipe out the subsystem information, that card will not work in the integrated slot. Okay, so we didn't touch that. We just simply changed the firmware over, and it seems to be working, or at least the PCI device is being detected right now. Let's go ahead as also run the SAS Flash utility to just confirm that we see the card. Alright, so here it is, and the SAS address is intact. We have it's identified as an LSI logic card. It's identified as a SAS 3081E. Alright, so everything seems to be working, and if we do LSCSI, you will see that I can see all 4 of the Hitachi hard drives that I have in this server. Alright, so one thing I want to share with you guys, whenever it comes to discussions online about this SAS6i/R card, there's some misinformation that gets passed around online, and this is not uncommon. Always verify the information you see someone post online, right? So let me just kind of show you an example of what I'm talking about. So here is I mentioned about this card in a Reddit thread, and you'll see here it says, never mind, ignore that. The SAS6/IR is based on an old LSI chipset 1068E, which is true, and won't see drives bigger than 2 terabytes. Buy an H200 or H310 and reflash it instead. Okay, so it says won't see drives bigger than 2 terabytes. Well, alright. So you see that I have 4 hard drives here, right? Let's take a look at one of them. Alright, so I'm just using Parted to look at the partition table, and you can see that this is a 4 terabyte drive, right? So what is this person talking about? I mean, obviously I can see a 4 terabyte drive. That's not a problem. In fact, let's go ahead and format that. Make sure I do it to the right drive here. Okay. So I'm going to go ahead and format that drive with XFS, and I'm going to mount it, and I'll show you that actually it shows up as a 4 terabyte drive. Okay, it's not just the partition table. Okay, so what this person is referring to, okay, is sort of a half-truth. Okay, this is not an entire bogus statement. The truth is that this chipset, this older SAS1 chipset, does have a 2 terabyte limit when it comes to SATA drives, but it does not have that problem with SAS drives. Okay, and if you want to understand that a little bit more in detail, I'll put up a card in the corner of this video here to my other video titled the 2 terabyte limit, and you'll get all the details there in terms of why this is and what's going on. But the short of it is that basically the chipset's not really able to handle large LBAs or 64-bit LBAs, and basically if you are using a SATA drive, that's the ATA commands have to go through what's called a SAS ATA translation layer, and that translation layer in the old SAS1 chipsets isn't able to handle those larger LBAs. Okay, But with SAS, that doesn't need the translation. So the communication basically goes directly from the hard drive to the host, right? And in that case, whether the chipset can handle the 64-bit LBAs or not doesn't actually matter. And so in that case, with SAS drives, it'll handle very large drives. You can put a 16 terabyte drive in this machine if you wanted to. Okay, so that's what that is about. Again, I highly recommend, if you're curious about understanding that a little bit more, check out that video called the 2 terabyte limit, and I go into all the details in that video about that. All right, so anyway, so this statement here is basically a half-truth. All right, and we'll see here in a moment here. Okay, the formatting is done. Let's go ahead and mount this drive. I'll mount it under /data. And as you can see, it's showing up as a 3.7 terabyte drive, which is effectively a 4 terabyte drive. And there's no problems formatting it, mounting it whatsoever. Okay, and that's because I'm using SAS drives here. Okay, so this is where, by the way, why I think this card has some unique utility here. See, with the R410, where your PCI slots are scarce, basically, you have really only one real PCI slot, and then you have this other integrated slot, right? And so if this SAS6i card will work for you in terms of the hard drive size you're using, if it's under 2 terabytes with SATA drives, this is fine. If you are using SAS drives, there's no size limit. You don't have to worry about that. That's fine. Okay. Then you can basically save yourself a PCI slot, which allows you to expand the server in other ways, right? If you decide that you can't use this SAS6i card, then you basically end up sacrificing that integrated slot. So I think this integrated slot has some utility if you are able to use the SAS6i card. Okay, that's a very hard thing to say for me, apparently. So SAS6i. Okay. So anyway, this is why I'm pointing out this card. Normally, I don't recommend any old SAS1 cards, but in this case, because the PCI slots are so scarce in the server, by using this card, and if your use case will work using that older SAS1 card, then you get to save yourself a PCI slot for other expandability. So for example, if you wanted to use this R410 as a starter NAS, right, and you're using SAS drives, and you can get away with using this SAS6i card, then you have that PCI slot open up for example, an external HBA. So that later on down the road, when you want to expand your NAS, you instead of just upgrading the entire server, you could add a disk shelf and use an external HBA to run the disk shelf through that external HBA card, right? So you could basically use this R410 as kind of a NAS controller head and just simply add more disk capacity. So I think, and so that's why I think this is an interesting option, that where I normally would not recommend a SAS1 card for the various limitations regarding SATA hard drive limits. I think this brings some interesting possibilities for the R410 in particular. Okay. All right, so we've already mounted the drive. Now, here's the other thing. So we know that hard drive size limitation is only an issue with SATA. So let's say you're going to use SAS, or you're building this from scratch, and up front you're going to, you know what you need to get. You're going to get this card, and you're going to get SAS drives, and you're good to go as a starter NAS or whatever it is you're going to do with R410. But another factor we want to consider here is performance, right? So is the SAS6i card performant enough for the 4 hard drives that it's going to drive inside the R410? And that's a question that we're going to try to find an answer to today here in the video. So I'm going to run a couple of benchmarks on these 4 drives. There's actually four terabyte drives, and I'm going to put them together in a RAID 0. And the reason for that is I don't want to, I want to show you basically the performance capability of the storage subsystem here. I don't want to add any other factors. For example, if I were to use like RAID 5 or RAID 6 or RAID Z1 with ZFS, or even ZFS. I'm not going to use ZFS, by the way. You guys know I love ZFS, and there's all sorts of benefits to it. But I'm not going to use it today because I really want to kind of limit the different factors that can influence the benchmarks today. So I'm simply going to use Linux's native MDADM software RAID capability to build a RAID 0 volume across those 4 drives, which, you know, basically is going to give me probably the simplest way to extract the most performance out of those 4 drives. If I were to use ZFS, you know, there's the question of, well, if I were to use anything with parity, so if it's like a RAID 5 or RAID Z1 or something like that, you know, then we have to consider, you know, the CPU overhead of calculating parities and stuff like that, right? And so I want to, you know, basically not have that factor involved here today. And if I use just ZFS with a stripe, which would be equivalent of a RAID 0 effectively, but because ZFS does, you know, some very intelligent things with how it allocates data with copy on write, and also the checksums on the blocks and all this other, you know, basically all the extra enhancements that you get with ZFS, I want to take those out of the equation for today. Okay, I want to basically just show you what this hardware is capable of in its kind of rawest form. Okay, and so I think the best way to accomplish that today is to use software RAID 0, where there's no parity calculation, so there's not a lot of CPU overhead. It's basically data being spread across a bunch of hard drives and you know, read from a bunch of hard drives, and that's all we're going to do. Okay, so now before we get started on that, since I've already got one drive mounted, I'm also going to benchmark one single drive just to get a baseline of how well these drives perform. And then we'll do the RAID 0 and we'll benchmark that. Now later on in this video, I'm going to also show you another option with a SAS2 card. So if this card, for whatever reason, if we, you know, at the end of this video, when we compare the performance numbers and you realize, like, you know, there are reasons for you not to want to use this SAS6i card and you want to go with the SAS2 card, then, you know, I'm going to show you how to set up a SAS2 card. Basically, where we're going to use an H200, and we're gonna have to change cables, and I'll show you all that later on when we swap over to that. But basically, by the end of this video, you should see the comparison between using the SAS1 card versus a SAS2 card, and you can decide for yourself what works best for you. Okay, all right. So let's get started with doing this benchmark. So here I am in the /data folder, which is just one of the hard drives formatted with XFS, just default options, no tuning, nothing special here. Okay, like I said, I'm really trying to keep this simplistic. I don't want too many factors involved, and so I'm mostly going to stick with default. So first test we're going to do, very simplistic test, is just to use DD to check for sequential writes and sequential read throughput. Okay, so oh, you know what? Before I get started, I'm having some problems with the Java KVM where sometimes if I press a key, it just kind of repeats itself. It goes kind of nuts. So instead, I'm going to just log in over SSH and avoid that problem. So here's the IP address of the server. Let me close that, and we're going to log in remotely. So let me open up a couple of terminals here. Let's go ahead and open. All right, so bear with me for a second while I log into the server over SSH. Oops. All right, so I'm logged in over SSH right now. On these right side windows, I'm going to run a couple of monitoring tools. So I'm just going to run IOstat, and this will give me an idea of what's going on with the IO subsystem. I'm also going to run top, and this will give me an idea of what's going on with like CPU and I/O weights and stuff like that. Okay, and in the left terminal, I'm going to go and run the benchmarks. And by the way, I created this spreadsheet here, and you guys might have seen this in my previous benchmarking videos. I'm going to kind of focus mostly on large writes and reads. I find that most people who are using a NAS at home are handling larger files versus like small files. Now, if you're running VMs and stuff like that, you might be more concerned about smaller record sizes. But if you're running a NAS to store your photos and videos and stuff like that, most of the time we're talking about fairly large files. So the benchmarks today are kind of going to be focused more towards that than, say, something with the smaller record sizes like BitTorrents and databases and stuff like that. Okay, so I'm basically going to run two different, I'm going to run two tests with DD, a sequential write and sequential read, and then I'm going to use IO Zone to run three different tests, basically sequential write, read, and random IOs, and we're going to record all that. Okay, I'm going to run this across four different scenarios. Okay, first with the SAS6i card that we have right now, we're going to do a single disk test just to get the baseline performance of a single drive. This is a 4TB Hitachi SAS drive, 7200 RPM, by the way. And then we're going to glue those four hard drives in the R410 together into a RAID0 set, and we're going to repeat those tests and just get an idea of how well that it scales up across four hard drives. And then we're going to go talk about the SAS 2008 controller, which would be the H200, later on in this video. All right, so let me put this spreadsheet away for a little bit, and we'll get started with the DD test. So I usually run this with status equals progress, just so I can get a little bit of visual feedback. We're going to read in a bunch of zeros, and we're going to write to this drive a file I'll just call speed test. And we'll use 1 megabyte block sizes, and we'll basically write 10 gigabytes. Now, one thing I want you to know, this server actually has 32 gigabytes of RAM, and if you've used Linux quite a bit, you know that Linux is very aggressive in using RAM for caching. And so when I first run this test, you might see a slight spike because it's not actually writing to disk yet. It's going to be writing to cache first. And so in order to limit the size of what we need to do to kind of break out of the cache, I've booted this system up with a limited amount of RAM. I basically limited to about 4 gigs of RAM. And so you can see here the amount of memory available is fairly low. Although the system hardware-wise has 32 gigs of RAM, the Linux kernel is booted up to only see about 4 gigs of that RAM. Okay, and that way, so I'm mentioning this because this DD test, we're going to only be writing about 10 gigs of data. And if we had 32 gigs of RAM, that whole 10 gigs would end up being cached in RAM anyway, and so we would not be able to test the performance of the I/O storage subsystem. But since we're limiting this to about 4 gigs of RAM, writing 10 gigs will definitely exceed that. And so we're going to, towards the end of this run, you're going to basically see the native performance of the I/O storage subsystem. All right, so let's go ahead and run this test right now. So yeah, you'll see that burst in the beginning here where it's like 600 megabytes a second. Okay, so yeah, that single hard drive is not doing 600 megabytes a second. That was basically writing to RAM. And as you'll see here, the memory amount free is shrinking to a point where it stops shrinking. That basically means it's okay. It's utilize all the RAM it can to cache, and now we're going to be seeing like basic native I/O performance. And you'll see here, by the way, in IO stat, it's actually writing about 180, 190, 200 megabytes per second to the hard drive. So that's roughly what our actual native hard drive bandwidth capacity is right now. And you'll see this here in the DD test that it's now settling down at about 207 megabytes per second, and that's fairly reasonable for this drive. It's a 7200 RPM SAS 4 terabyte Hitachi drive. All right, so we got a number of about 206 megabytes per second. Let's go ahead and record this. So single drive with this, we'll record this at 206. All right, So let me close that. Now we're going to read that file back and send it to dev null, which is basically the waste bin in the Linux world. But before we do that, we need to clear the cache, because I don't want to be reading out of cache. So you can do this with this command where you basically write the number 3 to this location in the proc file system. So it's proc/sys/vm /drop_caches. So when you do that, you'll notice over here on top, you'll see how the amount of free memory just like skyrocketed again. That basically means like everything that was cached just got dropped, and so all that memory is like freed up again. All right, so we're going to rerun this now, except in the other direction. We're going to read in the file that we just created in /data/speed test. We're going to output that to dev null. And again, we're going to use 1 megabyte block sizes, and we'll just have it read to the end of file, so I don't need to specify a count here. But it's basically going to read that same 10 gigabyte file back to us. So, all right, let's go ahead and do this. Okay, so we got about 198 megabytes per second in terms of read speeds from that single drive. Let's go ahead and record this here. All right. So we can see that this hard drive seems to, at least in this configuration, seems to write a little bit faster than it reads. All right, so next is the IO zone test. So let's go ahead. I'm going to delete this file that we just created, so we don't need that anymore. And we're going to run IO zone in the following fashion. All right, so I'm going to use 2 gigabyte files. I'm going to use 1 megabyte records, just like we did with the DD test. And we're going to run 3 different tests. We're going to do the number 0 test, which is a sequential write test, and the number 1 test, which is a sequential read test, and then the number 2 test, which is a random read and write test. I'm going to use 8 threads. Okay, so that's what T8 means. This server has 2 quad-core CPUs, so it's got 8 threads, 16 threads, or sorry, 8 cores, 16 threads. I'm just going to use 8 threads. So yeah, and then stride size, we're going to have 64. And I'm going to do a -+U for utilization. So this is going to provide us with some utilization information on the CPU. And I want to see that because I want to make sure that we're not pegging the CPU. All right, so you know, it's hard to test. So whenever you're testing IO storage subsystems, you have to be very conscious of the fact of where your bottlenecks are. And sometimes, you know, whatever particular benchmark you're using might be so CPU intensive that you're not really seeing the bottleneck in the storage subsystem, but you might be seeing it in the processor, because it, for example, might not be able to generate as much of an IO load as the storage subsystem is actually capable of handling. So we want to make sure that since we're doing 8 threads, that our CPU utilization isn't pegged like at 800%, which is 100% for each thread. So if we saw this, if the results showed us that, you know, the CPU utilization was 800%, then we want to be a little bit skeptical about the numbers we got, because we're basically hitting the limits of what the processor can do, and we might not be actually seeing the limits of the storage subsystem. So that's why I want to be able to see the CPU utilization with that option. Now, as I mentioned earlier, this system only effectively sees about 4 gigs of RAM, and it's going to try to use some of that for caching, right? So, so I picked these numbers for a very particular reason. I'm going to use 2 gigabyte file sizes, and each thread is going to create that 2 gigabyte file. So in total, we're going to be dealing with about 16 gigabytes of data, which is far exceeds the 3 or 4 gigabytes of RAM that the system has. So this is my way of basically working past the caching capability of the system so that we can actually see the performance of the storage subsystem. All right, so let's get started with this benchmark and go ahead and run IO zone. Alright, looks like our benchmarks are done now. Let's go ahead and record some of these results here. All right, so now as far as random I/O, obviously these are hard drives. We're not going to expect huge performance in random I/O. So this seems consistent. It's about a little more than half of its sequential performance. All right, so that's it for the single drive test. Now let's get to the interesting stuff. And let's now use all four hard drives in a RAID 0. So let's create dev md0 and RAID devices. We've got 4 of them. Level is RAID 0, and I don't want it to do any initialization because that'll probably disrupt our benchmarking. So I'm just going to assume it's clean. And this is for drives B through E. All right. Okay, so there's our RAID array. And let's format this so we can mount it. MKFS, XFS, dev md0. All right, formatting is done. Let's go ahead and mount this. So dev md0, we'll mount it under /data again. All right, so you'll see now we have a /data that is about 15 terabytes. Basically, it's the 4 times 4 terabytes there. All right, we'll start again with the DD test just to get an idea of sequential performance. So let's see if I can just recall that back from the previous one. Okay. So this is the sequential write test with DD, and let's see how this goes. All right, so we got 799. All right, so that's pretty impressive. Oh, sorry, wrong column. So that's, to me, is pretty impressive, because if a single drive can do about 200, with 4 drives in RAID 0, we're almost scaling completely linearly, meaning that we're able to exploit the full capability of each of those 4 hard drives, because this is 200 is basically 1/4 of 800 here, right? So and this is again on a really ancient SAS1 controller. So this is why I keep saying that I don't normally recommend SAS1 controllers. But in this use case where you can save yourself a PCI slot by using this SAS6i card with SAS drives, maybe it'll do just fine, right? Because if it can scale linearly like this on those 4 hard drives, then it's not bad. It's not bad. Now later on we're going to compare this to what we see with the H200 card. We'll see how that compares. But for now, this is looking pretty good. All right, so let's go ahead and drop to cache, and we're going to then run the sequential read test and see how that goes. We got 774. Again, that's pretty darn good for a SAS1 controller. Okay, so on to the IO zone test. Let me delete this file we don't need, and here's the IO zone command we just used before. So let's go ahead and run this. Again, this is going to take a while. I'm going to fast forward through this. I'm not going to cut it out, by the way. If you guys are wondering why I don't just cut out and skip forward, is that I kind of want you to see the benchmark, even if it's fast forwarded, just so you kind of get a sense of what's going on. But I'll fast forward it enough so that you're not spending too much time just watching this benchmark run. But anyway, let's go ahead and do this. Our benchmark is done. Let's go ahead and record the results here. All right, so the results are fairly consistent. Basically, for sequential writes and sequential reads, we're scaling pretty well, in terms of single drive versus the 4 drives in RAID 0. Random I/O, obviously, again, we're talking about hard drives here, so we can't expect that to scale very well, especially with random. So anyway, so those are the numbers we're getting for RAID 0 across the 4 hard drives in the R410 using the old SAS6i in IT mode. Okay, now if you look at these numbers and you're like, hey, you know, those performance numbers seem perfectly fine for what I'm using or what I need to do, then this is definitely a viable option for your R410. And if that's the case, you can save yourself a PCI slot and use that PCI slot for something else. So for example, if you are maybe also running Plex on this machine, you might want to add a little GPU to do some Plex transcoding, right? So that it really opens up some options for you on this R410. And this is the primary reason why I say this card may still have some utility. Okay, so by the way, if you're thinking that right now, and you're thinking, hey, I really think this would work for me, and I want to free up that PCI slot, I do sell these Dell SAS6i cards already flashed to IT mode at my store. You'll find the link in the description of this video. So if you want to just order that from me, go ahead and check out that link, as well as the cable that goes with it if you don't have the cable, or if you somehow lost a cable, or you know, whatever the reason. If you need the cable, you need the card, I've got them in my store. Go check it out. Okay, now the next step is let's talk about the H200 option. We can go ahead and shut this machine down now, and let's get back into the lab, and we'll talk about the SAS2 option for this R410. So we're back here in the lab looking at the inside of the R410. We just finished the performance test on this SAS6i card, and we got some pretty impressive numbers. All right, but we know that one limitation with this card is that it cannot handle SATA drives that are larger than 2 terabytes. So in that scenario, you know, if that's all you've got and you absolutely have to use your SATA drives that are greater than 2 terabytes, this is not going to work for you. So the alternate solution is to use this card here. So this is a H200 that has been flashed to IT mode, and we're going to install this card in the normal PCI slot. We're going to remove the SAS6i card, and we'll have to change out some of the cabling here. So let's go ahead and get started with that. So we're going to remove the SAS6i card first. Let's pull that out. Okay, and put that aside over here. And we're no longer going to be able to use this cable that goes to the riser here, because that's what is connected to the integrated slot. And since we're not going to be using that, we're going to have to remove this cable as well. There will be an alternate cable, and I'll show you that in a second, for installing an H200 here. Alright, so we're going to put this cable aside with the SAS6i card. Alright, so we're going to install this H200, which has been flashed to IT mode, and it's going to go in the normal PCI slot, so we've got to remove the PCI slot cover. Put this in its place. Okay, and like I said, we need a different set of cables. So the cables that you're going to need, if you absolutely have to go with this setup with a normal PCI card like this H200, you're going to need a specific Dell cable. Now this is not a cable you're going to be able to find in the aftermarket easily, because it's one of these split cables again, where it takes 4 SAS connections or SAS lanes from a 8087 connection and splits it into 2 8087 connections, one's a right angle and one's a straight, but these only carry 2 SAS lanes each. Okay, so you're going to have to get this very specific Dell cable, and I'm going to read the part number to you. I'll also put up a picture of it if this doesn't show on the camera very well, but basically it is Dell part number N262J. Okay, and I'm going to try to carry some of these in my store, but I don't have many of them, but if I can source more of them, I will. And so anyway, I'll leave a link in the description of the video, so go check them out. If I have them in stock and this is what you need, feel free to buy it there, or I've given you the part number so you can also source it independently wherever you like. All right, so let's get this cable installed. Let's see if I can figure out how to orient this best. So I think, yeah, I think this is probably the best way to do this. Let me snake it under this cable here. And I'm going to plug in the 8087 right angle connector first, just so I have everything in the right position, and then I'll route it under the cable management hooks and clips here. All right, and then this cable, instead of going this way to the riser, goes it instead will go through this other channel, and we'll plug it into SAS port A. Okay, so that's how that cable works. It basically goes directly into the H200 like that. Now, I know I was thinking about this. Wouldn't it be nice if there was a way to install like an external 8088 port here that connected to this 8087? That way you can actually make use of the second port. Because the way this is set up right now, you're kind of sacrificing this one port, you know, which is kind of, to me, a little wasteful. It would be nice if we could redirect that port to an external application so that you can maybe drive a disk shelf with that, or do something else with it at least. Okay, so that's how you get an H200 installed in the R410. And this will fully support very large SATA drives, SAS drives, everything. Okay, so there's no more hard drive size limitation by using the H200. All right, so I'm going to buckle the server up. We're going to fire it back on and get back at the desktop and run some benchmarks, and we're going to take a look at how this performs. All right. All right, so I've logged in to the server again after booting it up with the H200 card installed. So let's just verify that we see that card here. Okay, so you'll see that we have a SAS serial attached SCSI controller. It's a Broadcom LSI SAS 2008, and it's got the Dell subsystem vendor and PERC H200 integrated as the subsystem product ID. All right, and this is the same card that I sell in my eBay store. So these cards are designed to work in the integrated slot when that's a viable option. In this case, it's not, because the integrated slot is a totally different form factor. But this would work, for example, in the R710, R610, and some other servers as well. So anyway, so we've got the card here, and if we do LSCSI, we see that we see the 4 Hitachi drives, same exact Hitachi drives that we had earlier. And let's start by benchmarking one of these drives by itself. Okay, so let me do MKFS on dev SDA, and we'll mount this up afterwards. Oh. Alright, looks like we're done formatting here, and I have a IO error. I'm not really sure what that's about. Let's see if we can mount this. Slash data. Alright, no problem mounting it so far. So here is that 3.7 terabyte, so roughly 4 terabyte drive mounted in slash data. Let's get into slash data. Okay, so the first test we're going to do on the single drive is again the DD test. So let me see if I can pull that up from before. Yep, here we are. Okay, and same thing, we're going to basically run this test with a 10 gigabyte file, and as I mentioned earlier, this system only has about a little less than 4 gigabytes of RAM, so it won't be able to cache all of that, and so we should be able to see the native performance of the hard drive here. Alright, let's go ahead and get this done. Alright, looks like we got 205. So that's more or less the same as what we got before. Alright, so we're really not seeing much of a difference between the H200 and the SAS6i card right now. Let's go ahead and drop the cache, and we will now do the sequential read test. Alright, so we got 198 megabytes. Let's go ahead and record that. That is pretty much exactly identical as what we got before. Alright, finally, we're going to do the IO zone test. Let me delete that file. And here we go. Alright, so IO zone is now done, and there's some interesting results there. But let's go ahead and just take this one step at a time here. Okay, so as far as single drive performance goes, there really isn't much significant difference other than this here seems difference. That's like almost a 20% jump from here to here. But otherwise, it's almost identical. It is in fact identical in several places here. So, all right. So let's now get to the more interesting part. So we're gonna create dev md0 RAID devices 4. Level is RAID 0, assume clean, dev SD A through D. Failed to write metadata. Alright, let me, I'm going to pause the video here and just kind of investigate what's going on here, and then I'll come back. Alright guys, sorry about that. It looks like we might have had a loose cable or something like that, but anyway, I think everything should be better now. Let's continue where we left off. So we got the 4 drives. We just finished running the benchmarks for a single drive with the H200 controller. We're going to create a RAID 0 now with the 4 drives and then rerun those benchmarks. So alright, let's go ahead and do that. Let's see if I can maybe recall that command. Yep, so create dev md0 RAID devices equals 4, RAID level is RAID 0, assume clean. Alright, so let's go ahead and do this. And let's format the RAID array. So, alright, let's just force it. Alright, so we've got the file system created. Let's go ahead and mount this now. Alright, so there is our roughly 16 terabyte RAID array under /data. So let's go there. Alright, there we go. We're going to basically sequentially write a bunch of zeros, 10 gigs worth. Okay, so let's record this. We got 792. So pretty much not a lot of difference compared to using the SAS6i card. Alright, let's go ahead and drop cache, and we will do now the sequential read into dev null. We got 774, which is identical to what we got with the SAS6i card. And next we're going to run the IO zone test. So let's, before I do that, let me just kind of get rid of this file. And IO zone, there we are. Alright, let's get started. Alright, so IO zone is done. Let's go ahead and record some of these numbers. Let's take a look at this. So for the most part, the SAS6i card with these 4 terabyte SAS drives, 7200 RPM Hitachi drives, the performance is more or less the same, except for the random writes is a little bit slower on the H200 versus the SAS6i. So I can't really explain why that is. The other performance numbers are basically more or less the same. So this is again why I say this card, this old SAS 1 card, if you don't have to worry about the SATA drive size limitation is really not that different than the newer H200 or anything else really. So it's perfectly adequate for running a NAS just with 4 hard drives. So long as you're using SAS drives, you don't have the you don't have the problem with, let me see if I can spread this out. Yeah, you don't have the problem with the drive size limitation. And so this makes for a perfect little setup that allows you to free up that one PCI slot and do other things with that other PCI slot. So anyway, if you are using SATA drives and greater than 2 terabytes, you will have to get this H200. I've got the H200, I've got the SAS6, and I've got the cables in my store. I'll leave all the links in the description down below in this video. But anyway, I just wanted to show you guys this option here because I thought this was really interesting, and I didn't actually know what the performance numbers would be like. I figured they'd probably be pretty close, but they're almost identical really, other than this one thing. And honestly, I wasn't expecting the H200 to be a little bit slower in any way. And although it seems to be for random writes, and I really can't explain why that is the case, but otherwise they're almost identical. And I was really expecting the H200 to be maybe a little bit faster, but not by much. But in this, from what I can tell here, it's almost identical across the board, other than this random write with 1 megabyte records. So, and again, I can't really explain that, but yeah, so there's something to be said about this old SAS1 card. It certainly is still very much useful and definitely a viable option, so long as you don't have to worry about the 2 terabyte limit with SATA drives and you're using SAS drives or drives that are less than 2 terabytes in general. So anyway, I'm going to conclude the video here. I think this is probably long enough. This is took a little bit longer than I had expected. But anyway, those are the storage options for the R410. I think I'm going to go with the SAS6i, so I'm actually going to go back to the lab and swap that card out, the H200 out for the SAS6i, and leave the PCI slot open so that maybe we can explore some other possibilities with the rest of this video series on working on this R410. So anyway, I hope you find this information useful. I hope this kind of opens your eyes to some new possibilities. If you have this server or you're planning to buy the server, hopefully this gives you some new ideas. And again, if you need any of this stuff and you don't want, I showed you guys how to flash the card, but if you don't want to flash the card yourself, check out my store. I'll have these in my store as well as the cables. So check out the links in the description of the video. If you like this video, if you found this video helpful, please give me a thumbs up. And be sure to subscribe if you're new to the channel to get notified of the next couple of videos in the series if this is something that interests you. But anyway, thank you very much for watching and have a great day. Bye-bye.